In this chapter, we are going to introduce agents. Now, agents, I think, are one of the most important components in the world of AI. And I don't see that going away anytime soon. I think the majority of AI applications, the intelligent part of those will be almost always an implementation of an AI agent or multiple AI agents. So in this chapter, we are just going to introduce agents within the context of LangChain. We're going to keep it relatively simple. We're going to go into much more depth in agents in the next chapter, where we'll do a bit of a deep dive, but we'll focus on just introducing the core concepts and, of course, agents within LangChain here. So jumping straight into our notebook, let's run our prerequisites. You'll see that we do have an additional prerequisite here, which is Google search results. That's because we're going to be using the SERP API to allow our LLM as an agent to search the web, which is one of the great things about agents, that they can do all of these additional things and LLM by itself obviously cannot. So we'll come down to here. We have our Langsmith parameters again, of course. So enter your LangChain API key if you have one. And now we're going to take a look at tools, which is a very essential part of agents. So tools are a way for us to augment our LLMs with essentially anything that we can write in code. So we mentioned that we're going to have a Google search tool. That Google search tool is some code that gets executed by our LLM in order to search Google and get some results. So a tool can be thought of as any code logic or any function in the case of Python, any function that has been formatted in a way so that our LLM can understand how to use it and then actually use it. Although the LLM itself is not using the tool, it's more our agent execution logic, which uses the tool for the LLM. So we're going to go ahead and actually create a few simple tools. We're going to be using what is called the tool decorator from LangChain. And there are a few things to keep in mind when we're building tools. So for optimal performance, our tool needs to be just very readable. And what I mean by readable is we need three main things. One is a doc string that is written in natural language, and it is going to be used to explain to the LLM when and why and how it should use this tool. We should also have clear parameter names. Those parameter names should tell the LLM, okay, what each one of these parameters are. They should be self-explanatory. If they are not self-explanatory, we should be including an explanation for those parameters within the doc string. Then finally, we should have type annotations for both our parameters and also what we're returning from the tool. So let's jump in and see how we would implement all of that. So we come down to here and we have LangChain core tools, import tool. Okay, so these are just four incredibly simple tools. We have the addition or add tool, multiply, the exponentiate, and the subtract tools. Okay, so a few calculator-esque tools. Now, when we add this tool decorator, it is turning each of these tools into what we call a structured tool object. So you can see that here. We can see we have this structured tool. We have a name, description, okay? And then we have this arg schema. We'll see this in a moment, and a function, right? So this function is literally just the original function. It's a mapping to the original function. So in this case, it's the add function. Now, the description we can see is coming from our doc string. And of course, the name as well is just coming from the function name, okay? And then we can also see, let's just print the name and description, but then we can also see the args schema, right? So this thing here that we can't read at the moment. To read it, we're just going to look at the model JSON schema method, and then we can see what that contains, which is all of this information. So this actually contains everything, includes properties. So we have the X, it creates a little title for that, and it also specifies the type. Okay, so the type that we defined is float. Float for OpenAI gets mapped to number rather than just being float. And then we also see that we have this required field. So this is telling our LLM which parameters are required, which ones are optional. So we, in some cases we can even do that here. Let's do Z. That is going to be float or none. Okay. And we're just going to say it is 0.3. All right. I'm going to remove this in a minute because it's kind of weird, but let's just see what that looks like. So you see that we now have X, Y, and Z. But then in Z, we have some additional information. Okay. So it can be any of, it can be a number, or it can just be nothing. The default value for that is 0.3. Okay. And then if we look here, we can see that the required field does not include Z. So it's just X and Y. So it's describing the full function schema for us. But let's remove that. Okay, and we can see that again with our exponentiate tool, similar thing. Okay, so how are we going to invoke our tool? So the LLM, the underlying LLM is actually going to generate a string. Okay, so it will look something like this. This is going to be our LLM output. So it's a string that is some JSON. And of course, to load a string into a dictionary format, we just use JSON loads. Okay, so let's see that. So this could be the output from our LLM. We load it into a dictionary, and then we get an actual dictionary. And then what we would do is we can take our exponentiate tool, we access the underlying function, and then we pass it the keyword arguments from our dictionary here. Okay. And that will execute our tool. That is the tool execution logic that LangChain implements, and then later on in the next chapter, we'll be implementing ourselves. Cool. So let's move on to creating an agent. Now we're going to be constructing a simple tool calling agent. We're going to be using LangChain expression language to do this. Now we will be covering LangChain expression language or LSL more in a upcoming chapter. But for now, all we need to know is that our agent will be constructed using syntax and components that look like this. So we would start with our input parameters. That is going to include our user query and of course the chat history, because we need our agent to be conversational and remember previous interactions within the conversation. These input parameters will also include a placeholder for what we call the agent scratchpad. Now the agent scratchpad is essentially where we are storing the internal thoughts or the internal dialogue of the agent as it is using tools, getting observations from those tools, and working through those multiple internal steps. So in the case that we will see, it will be using, for example, the addition tool, getting the result, using the multiply tool, getting the result, and then providing a final answer to us as a user. So let's jump in and see what it looks like. Okay, so we'll just start with defining our prompt. So our prompt is going to include the system message. There's nothing, we're not putting anything special in there. We're going to include the chat history, which is a messages placeholder. Then we include our human message, and then we include a placeholder for the agent scratchpad. Now, the way that we implement this later is going to be slightly different. For the scratchpad, we'd actually use this messages placeholder, but this is how we use it with the built-in create tool agent from LangChain. Next, we'll define our LLM. We do need our OpenAI API key for that. So we'll enter that here, like so. Okay, so come down. Okay, so we're going to be creating this agent. We need conversational memory, and we are going to use the older conversation buffer memory class rather than the newer runnable with message history class. That's just because we're also using this older create tool calling agent. And this is the older way of doing things. In the next chapter, we are going to be using the more recent, basically what we already learned on chat history. We're going to be using all of that to implement our chat history. But for now, we're going to be using the older method, which is deprecated just as a pre-warning. But again, as I mentioned at the very start of the course, we're starting abstract and then we're getting into the details. So we're going to initialize our agent. For that, we need these four things. LLM, as we defined, tools, as we have defined, prompt, as we have defined, and then the memory, which is our old conversation buffer memory. So with all of that, we are going to go ahead and we create a tool calling agent, and then we just provide it with everything. Okay, there we go. Now, you'll see here, I'm passing the memory. I'm passing it in down here instead. So we're going to start with this question, which is what is 10.7 multiplied by 7.68? Okay, so given the precision of these numbers, our normal LLM would not be able to answer that, or almost definitely would not be able to answer that correctly. We need an external tool to answer that accurately, and we'll see that that is exactly what it's going to do. So we can see that the tool agent action message here, we can see that it decided, okay, I'm going to use the multiply tool, and here are the parameters that I want to use for that tool. Okay, we can see X is 10.7 and Y is 7.68. You can see here that this is already a dictionary, and that is because LangChain has taken the string from our LLM call and already converted it into a dictionary for us. Okay, so that's just, it's happening behind the scenes there. And you can actually see, if we go into the details a little bit, we can see that we have these arguments, and this is the original string that was coming from our LLM, okay, which has already been, of course, processed by LangChain. So we have that. Now, the one thing missing here is that, okay, we've got that the LLM wants us to use multiply, and we've got what the LLM wants us to put into multiply, but where's the answer? Right, there is no answer, because the tool itself has not been executed, because it can't be executed by the LLM. But then, okay, didn't we already define our agent here? Yes, we defined the part of our agent that is how LLM has our tools, and it is going to generate which tool to use, but it actually doesn't include the agent execution part, which is, okay, the agent executor is a broader thing. It's broader logic, like just code logic, which acts as a scaffolding within which we have the iteration through multiple steps of our LLM calls, followed by the LLM outputting what tool to use, followed by us actually executing that for the LLM, and then providing the output back into the LLM for another decision or another step. So the agent itself here is not the full agentic flow that we might expect. Instead, for that, we need to implement this agent executor class. This agent executor includes our agent from before. Then it also includes the tools. And one thing here is, okay, we already passed the tools to our agent. Why do we need to pass them again? Well, the tools being passed to our agent up here, that is being used. So that is essentially extracting out those function schemas and passing it to our LLM, so that our LLM knows how to use the tools. Then we're down here, we're passing the tools again to our agent executor. And this is, rather than looking at how to use those tools, this is just looking at, okay, I want the functions for those tools so that I can actually execute them for the LLM or for the agent. Okay, so that's what is happening there. Now we can also pass in our memory directly. So you see, if we scroll up a little bit here, I actually had to pass in the memory like this with our agent. That's just because we weren't using the agent executor. Now we have the agent executor, it's going to handle that for us. And another thing that's going to handle for us is intermediate steps. So you'll see in a moment that when we invoke the agent executor, we don't include the intermediate steps. And that's because that is already handled by the agent executor now. So we'll come down. We'll set verbose equal to true so we can see what is happening. And then we can see here, there's no intermediate steps anymore. And we do still pass in the chat history like this, but then the addition of those new interactions to our memory is going to be handled by the executor. So, in fact, let me actually show that very quickly before we jump in. Okay, so that's currently empty. We're going to execute this. Okay, we entered that new agent executor chain. And let's just have a quick look at our messages again. And now you can see that the agent executor automatically handled the addition of our human message and then the responding AI message for us. Okay, which is useful. Now, what happened? So we can see that the multiply tool was invoked with these parameters. And then this pink text here that we got, that is the observation from the tool. So this is what the tool output back to us. Okay. Then this final message here is not formatted very nicely, but this final message here is coming from our LLM. So the green is our LLM output. The pink is our tool output. Okay. So the LLM, after seeing this output, says 10.7 multiplied by 7.68 is approximately 82.18. Okay, cool. Useful. And then we can also see the chat history, which we already just saw. Great. So that has been used correctly. We can just also confirm that that is correct. Okay, 82.1759 recurring, which is exactly what we get here. Okay, and the reason for that is obviously our multiply tool is just doing this exact operation. Cool. So let's try this with a bit of memory. So I'm going to ask, or I'm going to state to the agent, hello, my name is James. We'll leave that as it's not actually the first interaction because we already have these, but it's an early interaction with my name in there. Then we're going to try and perform multiple tool calls within a single execution loop. And what you'll see when it is calling these tools is that you can actually use multiple tools in parallel. So for sure, I think 2 or 3 of these were used in parallel. And then the final subtract had to wait for those previous results. So it would have been executed afterwards. And we should actually be able to see this in Langsmith. So if we go here, yeah, we can see that we have this initial call. And then we have add, multiply, and exponentiate, we're all used in parallel. Then we have another call, which uses subtract, and then we get the response. Okay, which is pretty cool. And then the final result there is -11. Now, when you look at whether the answer is accurate, I think the order here of calculations is not quite correct. So if we put the actual computation here, it gets it right. But otherwise, if I use natural language, it's like, maybe I'm phrasing it in a poor way. Okay, so I suppose that is pretty important. So, okay, if we put the computation in here, we get the -13. So it's something to be careful with and probably requires a little bit of prompting and maybe examples in order to get that smooth so that it does do things in the way that we might expect. Or maybe we as humans are just bad and misuse the systems. One or the other. Okay, so now we've gone through that a few times. Let's go and see if our agent can still recall our name. Okay, and it remembers my name is James. Good. So it still has that memory in there as well. That's good. Let's move on to another quick example where we're just going to use Google search. So we're going to be using the SERP API. You can get the API key that you need from here. So serpapi.com/users/sign-in and just enter that in here. So you will get, it's up to 100 searches per month for free. So just be aware of that if you overuse it. I don't think they charge you because I don't think you enter your card details straight away, but yeah, just be aware of that limit. Now, there are certain tools that LangChain have already built for us. So they're pre-built tools and we can just load them using the load tools function. So we do that like so. We have our load tools and we just pass in the SERP API tool only. We could pass in more there if we wanted to. And then we also pass in our LLM. Now I'm going to use that tool, but I'm also going to define my own tool, which is to get the current location based on the IP address. Now we're in Colab at the moment, so it's actually going to get the IP address for the Colab instance that I'm currently on. And we'll find out where that is. So that is going to get the IP address, and then it's going to provide the data back to our LLM in this format here. So we're going to do latitude, longitude, city, and country. Okay. We're also going to get the current day and time. So now we're going to redefine our prompt. I'm not going to include chat history here. I just want this to be like a one-shot thing. I'm going to redefine our agent and agent executor using our new tools, which is our SERP API plus the get current date time and get location from IP. Then I'm going to invoke our agent executor with, I have a few questions. What is the date and time right now? How is the weather where I am? And please give me degrees in Celsius. So when it gives me that weather. Okay, and let's see what we get. Okay, so apparently we're in Council Bluffs in the US. It is 13 degrees Fahrenheit, which I think is absolutely freezing. Oh my gosh, it is. Yes, -10. So it's super cold over there. And you can see that, okay, it did give us Fahrenheit. So that is because the tool that we were using provided us with Fahrenheit, which is fine. But it did translate that over into an estimate of Celsius for us, which is pretty cool. So let's actually output that. So we get this, which is correct. Go to US, approximately this. And we also get a description of the conditions as well. It's partly cloudy with 0% precipitation, lucky for them, and humidity of 66%. Okay, all pretty cool. So that is it for this introduction to LangChain Agents. As I mentioned, next chapter, we're going to dive much deeper into agents and also implement that for LangChain version 0.3. So we'll leave this chapter here and jump into the next one.